Welcome to Astronomy for Everyone for June 2012. I'm John Shroyer, your host. With me tonight, we have two guests from the Ford Club. We'll be talking about deep sky objects that you see in the summertime. First is Mr. Steve Whitty, and he observes from a, well, tell us about your place.
Sure. I observe mostly from my driveway. Now, my driveway has a street light right next to it, so there's a street light right above it. And across the street is a grocery store with floodlights. And not too far away is a McDonald's with golden arches. I call my driveway the Mercury Vapor Observatory, but it's the closest place to observe from, and therefore it's the quickest to get to. And so I use that more than almost any other place that I observe. So I use a medium-sized telescope. It's about 10 inches in diameter, and sometimes I use small binoculars.
All right. Our second guest we have is Ken Anderson, also of the Ford Club. Ken, can you tell us about your telescope and your observing site?
Sure. I'm fortunate to live in a less light-polluted area, so the sky is fairly dark, and I do observe from my home, and I also observe from Island Lake and other darker sky sites. I do have a large Dobsonian 17.5-inch diameter telescope, and I do have binoculars up to 25 by 100 millimeters aperture.
Lots of binoculars, indeed. So what we're going to do is talk about objects that you can see in the sky that are outside of our solar system. That includes star clusters of two types. Globular star clusters are very tightly packed balls of stars, while open clusters are loose gathering of stars. We're also talking about nebulae, and that's basically glowing clouds of gas and dust that you can see. And we'll also be talking about supernova remnant, basically the leftover of a star that went kablooey a long time ago. The first object we will talk about is M13, and this is a brilliant globular star cluster. Steve, can you tell us about its location and what it looks like from your place?
Sure. So M13 is the great globular cluster in Hercules. So it's, as a great object, it's one of the brightest. It is actually visible in binoculars, so you don't really need a huge telescope to see it. It is one of the easier objects to find once you get used to finding objects.
Ken, how about, what do you see when you look at M13?
Well, also, I can see it in almost any one of my binoculars that I have, and a higher power makes it just look so much better. Globular clusters are small. It's only 20 minutes large, and but in my telescope I can see individual stars in the globular cluster, and the more power that I add, it just looks so much better. In my 10 millimeter wide eyepieces, it really brings it out, and you can even bring it up to higher power.
Yeah, globular star clusters are probably among the sexiest objects you can look at to a telescope. Imagine 100,000 diamonds packed together in a giant, very expensive snowball. Our next object is going to be M5, and it is also a globular cluster. It's located in the southern sky in Scorpius. Steve, what can you tell us about it?
M5 is a relatively bright cluster. It's pretty densely packed. It's absolutely awesome in the telescope. I usually don't attempt to find it in binoculars. I usually use the bigger scope. Sure.
Ken?
Well, M3, M5, and M13 all look about the same. The only thing is M13 is a lot easier to find because it has the keystone to help you find it. M5 is kind of out in the middle of nowhere, so it's a lot harder to find.
Okay.
That one's also 20 minutes wide.
Yeah, it's a really beautiful thing to look at. The problem with that cluster and the other things we're going to talk about is we're looking into the heart of the old Milky Way galaxy. So that part of the sky is filled with many different objects. We're now going to change and talk about glowing clouds of gas and dust. And the first one will be in the neighboring constellation of Sagittarius the Archer, and it's the Lagoon Nebula, known as Messier 8. Steve, what's your experience with the Lagoon?
So I almost exclusively use the larger scope with a nebula filter, which is an oxygen-3 filter. And so this filter only allows a very narrow amount of light. It's a very narrow frequency of light. And it happens to be a frequency that is not emitted by street lights and car lights and so on. But the nebula emits it. And so in my 10-inch telescope, I get to see the nebula, the cloud, on a black background, and that's very important.
Cool. Ken?
Well, the lagoon is actually a naked eye object. From my home, I can't see a naked eye, but if I go to Island Lake or Novi Community Sports Park, I can. So I can see the lagoon in any binoculars, with or without filters. The more light pollution filters I have on it, it does look better. So it does look better with O3 or ultra block. Just sweeping up in binoculars between M8 through the star cloud up through the Swan and Eagle, it just looks awesome in my 25 by 100 binoculars or any binoculars. In my large 17.5-inch Dob, the Lagoon Nebula is the only object I have seen that has color. And it's because it's so big, it's 90 by 40 minutes, and it's magnitude 6. So it's a really bright object, and it's awesome.
That's very good. We're now going to move on to another cloud of gas and dust, which is located nearby. It's the Trifid Nebula, known as Messier 20. It's also in Sagittarius. Steve, have you had any luck seeing it from your location?
Again, the oxygen 3 filter on the telescope is really the only way for me to see it from the heavy light pollution that I have.
And Ken?
The Trifid is a little bit harder to see than the Lagoon, but you do have a star cluster to help you find it, M81. And therefore, it's easy to pan up through and see it in the binoculars. And in the telescope, the nebula filters do help you see it, but to see the tri-black area in the middle, you do need to image that.
Now, besides the white and black, do you see any color in Trifid? Do you see any blue or red?
Well, the red is the emission part of the nebula, the blue is the reflection part of the nebula, and to see the colors of that, you either need a very, very large telescope or you need to image it.
Yeah, take a photo of it. Very good. And there is a great shot of the nebula. In photographs, in images, it's all digital now, it's really cool to look at. Now, the last object we're going to talk about in this section of the show is the Sagittarius star cloud. And it is, well, Ken, can you describe what it actually is for us?
Well, the Sagittarius star cloud is actually an opening in one of the arms of the Milky Way. So you're actually looking closer to the core of the galaxy. So Amira, he wrote saying that he really likes the terminology as a star window because you're looking through the arm of the cloud of the Milky Way. And that one is 90 minutes large. It's very large. You can see open star clusters in it.
How far away is that from us?
It is 15,000 light years away, and it's 500 light years across, and we see it 90 minutes wide.
So that's about halfway between us and the center of the Milky Way.
And it is so big you can't see it in the telescope. You have to see it in binoculars to see the whole thing.
Well, thank you very much. That'll be the end of our first section of the show on summer deep sky objects. We're now going to take a break. If you have any questions concerning anything in astronomy or telescope equipment, be sure to write us at astronomyforeveryone@gmail.com. Next off, we're going to have Mr. Steve Whitty with Astronomical Term of the Month.
The term of the month for June 2012 is SN 2011-DH. Now, SN, that's a supernova. And this supernova was discovered in 2011. And DH is the order in 2011 that it was discovered, and that turns out to be May 31st. SN 2011-DH was discovered in M51, which is a galaxy called the Whirlpool Galaxy. It's a relatively nearby galaxy at only 31 million light years away. Now, SN 2011-DH was the third supernova discovered in M51 in 17 years, though it is estimated that you only spot one every 40 years in a galaxy like this. The supernova was discovered and it was magnitude 13.5. Now, this is bright enough that it could be seen in a 10-inch backyard telescope. A month later, in June, it was magnitude 12, so it could be seen in a slightly smaller 8-inch telescope. Now, M51 is a great galaxy because it's photographed an awful lot. And the Hubble Space Telescope, which took this image, they were able to look through the archives of images taken, and they were able to find, at the right location, they were able to find a progenitor yellow supergiant estimated to be somewhere between 8 and 24 times the mass of the Sun. Now, this is kind of a weird space because if the progenitor is less than 20 times the mass of the Sun, then it leaves behind a neutron star. And if it's greater than 20 solar masses, it's thought that it would leave behind a black hole. So we don't know what the remnant is of this supernova. Now, this supernova is a type 2 supernova, and type 2 supernovae are formed by stars that are at least 9 solar masses and less than somewhere between 40 and 50 solar masses. And it's type 2 because it has hydrogen in the spectrum. Type 1s do not. Now, this was found in a spiral arm of a galaxy, and type 2 supernovae are generally found in the spiral arms. And that's because these are large stars, they have short lives, and they explode. In fact, I love these kinds of supernovae. They're a blast. Term of the month for June 2012 is SN 2011-DH.
Welcome back to June 2012's Astronomy for Everyone. I'm John Shore. With me today we have Steve Whitty from the Ford Amateur Astronomy Club. He observes from the Mercury Vapor Observatory in a light-polluted suburb. And we also have Ken Anderson. And Ken's also a member of the Ford Amateur Astronomy Club. And Ken observes from a slightly less light-polluted location. We're discussing deep sky objects you can see in the summertime. And we're going to pick up by talking about something called the Swan, or the Omega, or the Horseshoe, or even the Checkmark Nebula. Steve, can you tell us about the M17 and what you can see of it from your neighborhood?
Sure. So definitely, I'm interested in the Swan. We're in the Milky Way, and but the Milky Way is almost invisible from the light-polluted location. So when I'm looking at the object, and I'm looking at the object in a telescope, it's a bright enough object that it appears, and the background does not. All of the extra stars. Sometimes the Milky Way is easier to it's easier to see objects in front of the Milky Way from light-polluted locations because the Milky Way disappears and you're left with the object.
All right. Ken, how about from your location where it's a little darker?
Oh, well, like I said, right after I view the M24 star cloud, it's just an easy pan right to the Swan. That's normally how I find it. And it is a beautiful object. It's one of my favorite nebulas. It looks just like what it says it's supposed to look like. You see the check mark where you see that curve in the body of the Swan, and it is a really good view, whether you're using filters or not. But the filters do bring it out with a darker background.
Makes it stand out.
Yep.
Now, this particular nebula is located in the southern sky in summertime. You'll be looking toward the constellation of Sagittarius. The brighter stars make it look like a teapot, and you're looking above the spout of the teapot, which is almost due south later in June and also in July. Our next nebula, we're going to be following Milky Way over to the eastern sky and a little bit higher up than down toward the horizon, and this is called the Ring Nebula. It's located in Lyra the Harp. It features the bright star Vega, which is the brightest star of summertime. Now, from the Mercury Vapor Observatory, how does the ring look to you?
Well, it's almost straight overhead at some time of the night, usually during the summer, and the ring is a smoke ring. It really is a weird-looking thing. it is great in the 10-inch telescope with or without a nebula filter because especially if you're looking straight up, you're not looking through very much atmosphere, and therefore you have less light pollution to deal with. The Ring Nebula is a planetary nebula. That is, it is the gas that has been given off by a star in the last stages of its life.
So you're looking at what the sun's going to be looking like in 5 to 6 billion years.
Yeah, exactly. So the nebula portion, the planetary nebula portion, only lasts maybe 10 or 15,000 years. So you're looking at a kind of a small slice of time out of the life of a star.
And how about where you see it with your bigger telescope?
Well, the ring is only 1,500 light years away, and it is very small. It is only 1/2 light year across, and we see that as only 1 minute across. So this is one of the smaller objects that you're looking at. Hence, I've never seen this one in my binoculars, but it does look very nice, and it is one of my favorite planetary nebulas to look at. As Steve mentioned, it does look like a smoke ring, and all planetary nebulas do look a lot better, and you can find them a lot easier with O3 filters, because that's the excited oxygen that you see the most.
The light you can see the best. All right, very good. Our next object is actually, it's caused by the death of a star, but one that didn't just puff its gas out in the spouse. This star actually exploded in a supernova explosion. It's called the Veil Nebula, and it is located in the eastern sky in June, close to the horizon, in the constellation of Cygnus the Swan. Here we'll see a photo. Steve, do you have any luck with this, where you are?
Absolutely, absolutely. The oxygen 3 filter is absolutely necessary. You can't see it without it. You see nothing without it. It's amazing. The filter just sort of makes it jump out at you. The veil, in general, is a huge object, and you end up panning, eyepiece after eyepiece across the field to see the whole thing. I have a very low power 2-inch eyepiece, but I don't have an oxygen 3 filter for it, so I really have to pan at the moment.
Move the scope to see
Move the scope a lot.
How about you, Ken?
Well, the first time I saw the Veil Nebula in my own scope, it was a 10-inch scope, and the only way I could see it was at Island Lake with an O3 filter, and I tried many times. With my 17.5-inch diameter scope, I can actually see it with or without filters. It does look a lot better with the filters, and I always use my widest eyepiece, which is a 40 millimeter 70-degree field of view. Almost gives me like 1.5 degrees true field of view. And like the part that you showed up on the screen is the western half, and you do have to pan up and down to see that. It is very easy to find because it has a star that you just aim right at the star, and the nebula goes right through that star. It's a double star. And then I normally pan from that in the direction of the Cygnus arm or wing of the cross, and then I see the other half of the veil, which is a curved part of the veil. And they're equally awesome, but it does take a wide eyepiece.
If we can bring the picture up of the veil again, the part we're showing you is actually known as the witch's broom. There you go. Now, the next object we're going to talk about is another planetary nebula. You can see the star that Ken was referring to there, almost at the top center of your TV screen. The next image is also a planetary nebula. It's another star that has basically thrown off its gas. It's known as the Dumbbell Nebula. So you feel like working out, Steve, when you look at it?
Sure. It actually looks kind of like an apple core, and so you can either work out or you can be hungry. It also can appear very high in the sky, and so I can see it without a nebula filter, although a nebula filter makes it look way better. You get a lot more detail, especially from the Mercury Vapor Observatory. It's relatively easy to find in Vulpecula, as these things go.
And that would be what, the southeastern part of the sky in June?
It really is, yeah, southeastern part.
Okay. Ken?
Well, the Dumbbell Nebula is one of my favorite planetary nebulas. It is actually very large. It's 900 light years away, 2.1 light years across, and we see that as 8 by 4 minutes across.
So it's closer and bigger.
Yeah. And in my 10-inch, I saw it as the bow tie that Steve saw it, but in my 17.5-inch diameter, you see the bow tie, but then also a round circle around it. So it is one of the bigger ones, and I can actually see it in binoculars as a point with the end pointing to it.
Thank you, sir. Now, the next thing we're going to do is we're not going to ignore the northern part of the sky where the big and little dippers are. We're going to talk about the last two objects, and these are galaxies, M81 and M82. Now, here you'll see a map that shows you both the galaxies. M81 looks sort of like the Milky Way. It is a spiral galaxy. M82 is entirely different because, well, some people might say it doesn't get enough fiber. It's an irregular galaxy. Can you explain to our folks what that is, Steve?
Well, we have spirals and elliptical galaxies as the main sort of categories of galaxies. An irregular galaxy is basically anything else, and often an irregular galaxy is either one that has just formed or it has just had an interaction with another galaxy, so it's been stretched or distorted, or there are even rectangular galaxies out there. You know, you'd think, well, that would never happen, but almost anything goes.
Can you see it from your location?
I can only see one of the two from my location. The face-on, which is the face-on?
Spiral?
The spiral,
M81.
the M81.
Yes, sir.
This is the brighter of the two. It has what's called better surface brightness. And really, my skies are, the light pollution in the skies gives the sky a brightness, and the galaxies have to be brighter than the sky in order for them to be visible at all. So I get to see M81. I do not get to see M82. No filter helps me at all.
All right. Ken?
Okay, well, I have seen both of these in binoculars. Higher power definitely helps with galaxies, but they're a beautiful sight and one of my favorite galaxies in the telescope. And because M81 is brighter, I always find that one first, and then I see M82 in the same field of view with my wide power eyepieces. Now, galaxies are outside of our own galaxy, so these objects are 7 million light years away versus other ones being a lot closer.
You're telling me that this object, you're looking at it as it was, not today, but 7 million years ago.
That's correct. And also, M81 is 53,000 light years across. M82 is 22,000 light years across. And we see them as 26 by 14 minutes across and 11 by 5 minutes across.
So
and you do not use nebula filters for these objects because it just makes them dimmer.
So basically, M81 is about half the size of the Milky Way, and 82 is about a quarter of the size. Well, that concludes our segment on some of the great summer objects that you can see in the nighttime sky. We hope you enjoyed this segment. Next off, if you want to learn more about the shows and what we've done in the past, you can go to our website, which we have listed up. And next up will be What's Up in the Night Sky for June 2012. Welcome to What's Up in the Night Sky for June 2012. We'll start off, as we always do, with the phases of the moon. June will start with a full moon on the 4th. We'll then follow with the third quarter moon on the 13th. And then we'll have the new moon, which will be on the 19th. That means you won't be able to see any moon in all the sky, We'll wrap up the month with the first quarter moon on the 26th. Our next object in the sky is Venus. This is your last chance to see it as a separate object in the night sky. On June the 1st, it's barely going to be above the western horizon after sundown. Now, the next chance you'll get to see it is if you have a solar telescope is June the 5th, when it flies in front of the face of the sun, the transit of Venus. Going later on in the evening in June, you'll look to the southwestern sky for Leo the Lion, and you will find the red planet Mars. You're now going to wander over to the southeastern sky and look for a bright blue star, which is Spica. Right next to that will be the beautiful ringed planet Saturn. Now, Jupiter and Mercury are visible right before sunrise, actually. So it's going to be very, very hard to see, but you might be able to get a chance to take a look at them. Now, in addition, we have some dates coming up. On the 17th, you're going to have the crescent moon, Venus, and the beautiful star cluster, the Pleiades. They'll be all together in the evening sky. And that'll be located over in the west. Now, on the 29th, and these are people who have really large telescopes, or if you have a digital camera, you get a much better chance to actually capture this. Pluto will be in opposition. That means it'll be up all night long, and it's going to be located next to the globular star cluster. So basically you're looking for a very small dim dot on a giant cluster of brilliant dots. Lots and lots of stars. So like I said, if you have an astro camera, you have the best chance to see it. Now, also on the 29th at dawn, you're going to see the Hyades, and that's basically the V-shaped face of Taurus the Bull, the planet Jupiter, the planet Venus, the two brightest planets in the sky, and the seven sisters, the Pleiades. They'll all be together in the dawn sky on the 29th. You'll be able to see that with just your eyes. Now, it'll be, of course, just before sunrise. That's what's up for the night sky for June 2012. Thank you for watching.